Bonds are attractions between oppositely charged particles that has to do with what atoms are doing with their electrons when they combine. So sometimes they could gain electrons, they could lose electrons, or electrons could be shared. And the explanation of that goes back to periodic trends and the strength of attraction between the nucleus and the valence electrons, and even valence electrons that another neighboring atom may have. So the trend for this connects with Zepf and shielding by looking at electronegativity. We saw on the periodic table in general going left to right, electronegativity increases. Going bottom to top, it increases. So our top right is our highest attraction or electronegativity. The bottom left is the lowest attraction and electronegativity. So when we look at that, we're not just looking at an individual atom's electronegativity, but differences in electronegativity. So if I have two atoms in a bond, do they both have very strong attraction for electrons? Is one strong and one weak? Are they both in the middle? And that'll tell us what happens to the valence electrons. Will they share them? Will they gain and lose them? If they're sharing, what would that look like? You can do numeric calculations, and we'd see that it's kind of a spectrum here between being shared perfectly equal, being shared but shared unequally, and totally gaining and totally losing, and a lot of compounds that we might classify as polar or as nonpolar, covalent, or as ionic really share some properties of the things on each side of it. You can have an ionic compound that acts somewhat polar, a polar compound with some ionic properties, but we generally do like to classify things based upon what they have most in common with their properties, looking at that difference in electronegativity. So we're going to look at some general rules, but also understand that there's some outliers and some exceptions with each different type of bonding.